Hello, hello, hello. Here's some help on the parallel bars one for the assignment. So what we've got is this. We've got I think it's it's a steel thing like this, hollow tube, like that. And then we've got concrete in the middle and concrete in there, C for concrete. And then the blue is the steel. All right. So we've got to find our steel. So we've got to find the stress in the steel, symbol for stress in the steel, and stress in the concrete. Okay, we don't know what they are, but we do know, well, you know, that we know the Young's modulus of the steel, and we know the Young's modulus of the concrete, because in your question, let's say for our sake, it's different in the assignment. Let's say for the steel is 250, for the concrete is 12. It's different for you in your assignment. Okay, and let's say the length of this thing is, let's say it's 5. It's different for you. And let's say the outer diameter is 20 mil. Okay, as in outer diameter. Here, look. And the wall thickness is, I don't know, 2. They're different for you in your assignment. Okay, so we've got to find now stress in the steel, stress in the concrete, and you've also got to find the change in length. That's what we've got to find. Okay, you've got to find them things there. Now let me zoom a bit. See if I can move. No. Can I move this? No. Come on. No. Okay. So we've got a couple of formula. So here's the formula that we know for the parallel bar. So here's one formula: stress in steel over Young's modulus of steel equals stress in concrete over Young's modulus of concrete. That's one formula that we know. We also know this formula here. The force is stress in steel times area of steel plus stress in concrete area of concrete. Okay. Now, if you look in your assignment, we also know the force. So you'll have a number for force. Let's say minus 5 kilonewtons. It's different for you, right? So these are the main formulas here. Look, this one here and this one here. Okay. And we also know strain is change over original. And we also know that Young's modulus is stress over strain. Okay. That's the formula we need to use to solve this problem. Okay, so part A is we've got to find stress in steel and stress in concrete. Okay, stress in the steel, stress in the concrete. That's coming up. Okay, part A. We've got to work out now the stress in the steel and the stress in the concrete. So this is what we've got when it gives me a pen. So we've got this. What is this, basically? And then that's the round bit, right? And then, so you've got a round hollow tube, and then that's the steel there, look. That's the steel which we've got to find the stress in. And then it's filled with concrete. That's the concrete. Okay, so we've got to find stress in the steel and stress in the concrete. Okay. Now we know a few things. We know the force. The force is 5 kilonewtons. We know Young's modulus is 250, and Young's modulus of the concrete is 12. The length is 5. Okay, it'll be different for your numbers. Diameter is 20 mil, outside diameter, 2 mil wall thickness. So we know these things, right? And we know this formula, and we know this formula, and we know this formula, and we know this formula. So we've got to find now, with all of these numbers, Young's modulus of the concrete, Young's modulus of the steel, which we know. We know the force, right? We know the length. Okay, we also know that this hollow bar has got an outside diameter of 20 millimeters and a wall thickness of 2, which means we can also work out the area. Oh, it's moving. It moves when I don't want it to move. We can also work out the area of the concrete because it's a round thing, look, and we can also work out the area of the steel, which we can do. But first of all, we need to do some magic with this formula. Okay, so we've got this formula that we know. Stress in the steel over Young's modulus of the steel has got to equal the stress in the concrete and Young's modulus of the concrete. The problem we got there is that there's 2 unknowns there. We don't know the stresses. I don't know that stress and I don't know that stress. So I've got 2 unknowns. I don't like 2 unknowns. So what I'm going to do is I'm going to rearrange this formula. I've got 1 unknown. So I'm going to rearrange for stress in the steel. And all I'm going to do is this. Ready? Watch this. Stress in the steel equals Young's modulus of the steel times by stress in the concrete, all divided by Young's modulus of the concrete. Or, to make it look a bit better, Young's modulus of the steel divided by Young's modulus of the concrete times by stress in the concrete. It's the same thing. So now I've got a term for my stress in my steel, which I might be able to use. Okay, I know these Young's moduluses. Okay, so all I've done there is rearrange the formula. Okay. Now I also know this formula here for the force. Force is equal to, let's get a different pen. Force is equal to stress in the steel times by area of the steel plus stress in the concrete times by area of the concrete. That's just stress is force divided by area. So there's another formula. Don't forget, I know what the force is and I know what these areas are. I can work them out. Again, I've got 2 unknowns. I don't like 2 unknowns in the same formula. So what I'm going to do is, I'm going to see this formula here. I'm going to put that in here, in there. Look. I'm going to substitute it in there, which will give me 1 unknown. Okay, so watch this. So I'm going to, that formula here, I'm going to put it in there. It's going to look something like this. Force, right? And all I'm going to do now is substitute that formula, this formula, into there. So stress in the steel is the same as that, look. So all I'm doing is putting that in there, look. Also get different color, you know, so we can go with different color. So all I'm doing is this formula here, I put it in there, look. So we got that. Just instead of having stress in steel, I've got this formula here, which has got Young's modulus and stress in concrete. We'll times that by AS and plus that and that. So now I've got another formula, and the good thing about this formula is I've only got one unknown, which is this. I know everything else. The next thing I would do is work out the area of my steel and the area of my concrete. Okay, because I know, just draw that in. Don't like that really. I'll get rid of that. Get rid of that, get rid of that. So I've got this round thing like this. And in. So that's steel. That's my steel there, look, area of the steel. And then in here is filled with concrete. That's going to be the area of concrete. I know in my example it's 20 millimeters there. And the wall is 2 mil. So I can use pi r squared to find the areas of concretes, because I know it's a round thing. So you can find now the area of the steel and area of the concrete. Okay, because you've got one big circle, so you need to find the area in here, because you know that, because you know pi r squared. Okay, so you've got a big circle. How many? You've got a big circle, take away from a small circle. So you need to work out that area. I leave that for yourselves to work that out. Don't forget, area of a circle is pi r squared. So we've got big diameter is 20 mil, and small diameter is going to be, I don't know, 18, 16, like 16. For me anyway. So I can work out the areas of them things. For me, the area of my concrete is something like 201 times 10 to the minus 6. You have to work your own out. Do an example in class once, and then the area of my steel is going to be whatever it is. I've written it down somewhere. In the game, the area of my steel is 113 times 10 to the minus 6 square millimeters. Yours would be different. You'd have to work out your own. Okay, they're just two circles, take away one from the other. Okay, so now I know my area of my concrete and the area of my steel. I can now put it into this formula because I know everything. I know everything. All right, I know everything. I know the force, I know Young's modulus, I know areas. So here's my formula. F equals Young's modulus of the steel, Young's modulus of the concrete, times by stress in the concrete, times by area of the steel, which I know, plus stress in the concrete, times by area of the concrete. So I'm going to put in my numbers. I've got 5,000, because that's my force, equals 250 divided by 12. You haven't got to put the gigas in because they cancel out. Times by stress in the concrete, which I don't know, times by area of my steel, which is 113 times 10 to the minus 6. 113 times 10 to the minus 6. Okay, so that's perhaps one part of it there, look. Plus stress in the concrete times by the area of the concrete, which was 201 times 10 to the minus 6. I've just put my numbers in there. That's all I've done is put my numbers in. Look. So you should have numbers now for area of steel, areas for concrete. You've also got numbers for Young's modulus of the steel and Young's modulus for the concrete and the force. Just put your numbers in, okay, and work it out. So now I've got, let's work this out, 5,000. Okay, 250 divided by 12 is 20.83. Times by, I'll move that to there, look, so it looks a bit better. 10 to the minus 6. Is that right, though? I've got a feeling I'm wrong. No, I'm right. Am I right? I think I'm right. Yes, I'm right. So 113 plus stress in the concrete times by 201 times 10 to the minus 6. Okay, so all I've done there is put them numbers in. Oh, I've also forgotten to put in here me. I forgot to put in there, like, not concentrating. Whip that out. I've missed out. Give me a color, please. I've missed out times that plus that times 201 10 to the minus 6. So I've got 20.83, which is 250 divided by 12, 1113, so 111, so 113 minus 6 times by that. Okay. All I'm going to do now is 5,000. 20.83 times by this gives me 2.3 times 10 to the minus 3. Stress in concrete. Plus 201 times 10 to the minus 6. So I've got that stress in concrete. Okay, so that's like 2x. If I had, 2x plus 3x, I would have 5x, wouldn't I? So all I'm going to do now is add the 2.3 and the 201 together. So now it's a bit of algebra. So different pen. So I've got 5,000 equals 2.3 plus this gives me 2.5 times 10 to the minus 3. So now I've got an easy thing now. All I've done there is added 2.3 times 10 to the minus 3 plus 201 times 10 to the minus 6. So I can work out now my stress in my concrete, because I can do this. Stress in concrete is going to be 5,000 divided by 2.5 times 10 to the minus 3. That gives me a number of 2 megapascals. That gives me stress in concrete. Okay, that's one job done. Now I can find the stress in steel because I can use this formula here, this one here. Okay, so to find the stress in the steel, use this formula. You can do your own. Young's modulus of the steel divided by Young's modulus of the concrete times by stress in the concrete, which is there. You know the Young's moduluses and you know the stress in this concrete, which means you'll be able to work this out. Okay, so you now have a value for stress in steel and stress in concrete. Okay, I would now pause this video and go back and go over it again just to make sure you get the right numbers. So replay my video. Once you've done that and you've come back, we can then, the last bit we've got to do is find the change in length, because this thing's been squashed. So we've got to, I think it was part B, we've got to find the change in length. Okay, so we know that strain is change in length over length. And we also know that Young's modulus is stress over strain. So the strains are the same. The strain in the concrete equals the strain in the steel. So they're both the same. Okay, they're both the same in a parallel bar. So we can work out now the strain. I just picked the strain in the concrete because they're both the same. If you work them up, they'd be the same. So I know that Young's modulus is stress divided by strain, which means that strain is going to be stress divided by E. Okay. Now I know the strain in the concrete for me is 2 mega. There. So I'm going to do this now. So you do the same thing. Strain in the concrete equals 2 times 10 to the 6 divided by Young's modulus of the concrete, which is all the way up here somewhere. Young's modulus of the concrete is 12. 12. That will give me a number. It'll give you a number as well. Okay, so get that number. And you should find that the strain in the concrete will be the same as a strain in the steel. Okay, so once you've got the strain, you can then do this. So we know that strain is change in length over length, which means you can do change in length equals strain times by length. Okay, and you know the strain in the concrete because you've just worked it out up here. And you know the length because the length is, in my example anyway, 5 meters. So that's going to be 5. That will give you the change in length. And that'll be it. Part B done. So it's quite a lot. So pause the video, go back, pause the video and go back, pause the video and go back. So you've got to work out the areas, work out the areas, then use this formula to insert it. Okay, that's the formula you want there, really. That's the main one. That's the main formula there. But you've got to find the areas of the steel, areas of the concrete, go through it, put your numbers in step by step. Once you've got the stress in the concrete, use this formula to find the stress in the steel, and then find the strains. Okay, you've only got to find one strain because they should both be the same, and then the change in length. Okay, so hopefully that makes a bit of sense. It is quite a tricky one. We did, for example, in class, but this was a distinction last year. They've moved it up to a merit or down to a merit, so that's why it's a little bit tricky. So have a go at it, please. You should be all right. It might take you a couple of times, but have a go at it. Any problems, let me know. Ciao for now.